Hello students, today's lesson is an introduction to conics. In this unit we're going to study 4 different conics. We're going to study parabolas, circles, ellipses, and hyperbolas. So the purpose of this unit is to just introduce you to the standard equations for each of them and to talk a little bit about how you can identify the equation with the conic and then also how to convert an equation back into standard form if it's not already in standard form. Okay, so for the first one we're going to look at parabolas. Now we've already looked a little bit at parabolas, and the way a parabola is formed is by cutting this double helix cone here. So if I was to cut this cone right here with a plane, so a plane, then you would form a parabola shape. Okay? Now we have 2 types of parabolas. We have parabolas that open up and down, and we have parabolas that open side to side. In this first equation, we have x minus h squared, and it equals 4p times y minus k. And one thing that I forgot to mention is that all of these equations will be centered at the point h comma k. So let's write that up here. They will all be centered at h comma k. And if you'll notice in these equations, the h coordinate, which is the x coordinate of the center, it will always be with the x in the equation, and the k, which is the y coordinate, will always be with the y in the equation too. So you can always remember that way. Okay, so let's go back to the parabola. In this first example, if you notice, the way the equation is set up, we have 2 x values for every 1 y value. So that's one way that you can remember what kind of parabola it's going to be. You'll have 2 x's for every y. Okay, well, what does that look like? If you're looking at a graph, if you have 2 x's for every y value, let's say the y value is 2, and if I have 2 x's that have a y value of 2, they're going to be on either side, right? Well, the same thing if I have 1 at 1. They're going to be on either side. If my center is the origin, then you'll notice that this parabola is going to open up. So this equation is used whenever you have an up or down opening parabola. Okay? Vice versa, this other equation right here is when you have 2 y values for every 1 x. Okay, so what's that going to look like on the graph? Well, for every x, you're going to have 2 y's. So if I have 2 on the x-axis, it's going to have 2 y values. So I'm going to have maybe one up here and maybe one below it. The 1, maybe up and below. Again, if it's centered at the origin, it's going to look like this. So whenever you have 2 y's for every x, it's a parabola that opens left or right. Okay? Alright, now let's look at the circle equation. Alright, the circle equation is x minus h quantity squared plus y minus k quantity squared, and it equals r squared. So how is a circle formed? Well, a circle is formed when you cut this double helix cone with a plane and you cut it horizontally. It's going to make a circle right there. Okay? Well, again, this equation is based on when the center of the circle is at h comma k, and this r on the end here, when you have r squared on the end, if you take the square root of that, that's going to equal your r value, and r stands for the radius of the circle. So if I was to graph this, you would first start by graphing the center, and then based on what the radius is, you would go out that distance all the way around, and it's going to make a circle. Now, one way that you will recognize that it is a circle equation is this number on the right side that it's equal to. It will be a number other than 1. It could be 1, but the ones that people get confused on is that the circle equation and the ellipse equation is very similar. We have two things being squared, they're being added together. But the difference between the circles and the ellipse is that the ellipse will always be equal to 1, and if it's not, you'll divide it, and we'll talk about that later. But you'll start to recognize the difference between circles and ellipses. So now, next let's talk about the ellipse. An ellipse is formed when you have a plane and it cuts it, let me grab my pencil, sorry. It cuts it kind of on a slant like this, because you're going to end up with it's kind of like an oblong or an oval, but we call it an ellipse, okay? One thing that you'll notice about the ellipse when you're looking at the equation is that the equation will always have a plus here, whether it's opening long ways horizontally or long ways vertically. But we usually have two different numbers as a denominator, here and here. And the A value, or whichever one is the biggest value in the denominator, that's going to represent the side of your ellipse that is the longest. Okay, so let's write some of that down. When you have an ellipse, you will have two different lengths in the denominator. Each of these lengths, when you take the square root of them, they will represent the radius of that side of the ellipse. Okay, so in this particular one, if my A value is the biggest, I will have an ellipse that will be longer on the x-axis. So notice that the x-axis is what's up here. So it's going to be longer on the x-axis and shorter in the y direction. So it's going to look like this. Remember, I'm just doing rough sketches, so they're not perfect. Now, if my A value was the biggest under the y, then it's going to open long ways vertically and be shorter horizontally. So it would look kind of like this. Okay. So let me move this down. If the lengths are the same, so I'm going to put this in a different color. If lengths are the same, then it is a circle. Okay. Okay, the next conic is the hyperbola. The hyperbola is pretty easy to recognize as the equation because it's the only one that has the minus in between the x and the y's. It's also always equal to 1. Okay, you still are going to have different values on the bottom, so your a squared and your b squared should be different values. How a hyperbola is made is if I cut this double helix cone vertically but not directly in the center, it's going to make almost two parabolas. It's going to make one here and one here. And so we call that a hyperbola. Don't call it a hyperbola, call it a hyperbola. And just generally speaking, what you're going to do to graph this is we're going to assume that the a value is the biggest value again, and it's under the x. So you would go out that distance, and that would give you your vertices for your hyperbola. So it would be opening this way and this way. So whichever the bigger number is, if the bigger number is under your x value, then it's going to open horizontally. If the bigger number is under the y value, then it's going to open vertically. So you would go out from the center to these points, and then it would go like this, somewhat like this. No, my pictures are terrible. We just want to get a general idea of what it looks like. The other thing is that you will have asymptotes look something like this on each one of them. Of course they would be straight, but I'm just sketching them, okay? And that's how the hyperbola would be made. So we'll do lots of practice with this, and you'll understand what you're doing. Okay, so let's look at some practice equations, and what you're going to do on these is you're going to decide which conic it is, and then you're going to put it into standard form. So in the first one, we have y equals 1/8, parentheses, x plus 1 quantity squared plus 4. So hopefully you recognize that this is a parabola. Again, kind of a flag that tells you that it is a parabola is when you have only one, either x or y, being squared. Okay, now hopefully you notice that this is in vertex form, but we're going to get it into standard form. And if you'll remember what standard form looks like when you have an x squared, is we have x minus h quantity squared, and that's equal to 4p. P is just some number, so we'll talk about that when we talk about parabolas in general. But it looks something like this. So basically we need to move everything away from the quantity squared, the x plus 1 quantity squared. So the first thing we're going to do is we're going to move this 4 over, because we want to subtract 4 first, okay? So we have y minus 4 equals 1/8 of x plus 1 quantity squared. Well, now we need to get rid of our 1/8. Well, if you'll remember how to get rid of a fraction, we can't really divide by a fraction. We're going to multiply by the reciprocal instead, which would be 8 over 1, which is the same thing as just multiplying by 8. That's going to cancel off your 1/8. So over on the right side, you'll have x plus 1 squared. And then I would go ahead and leave it like that. You don't want to multiply it together, because if you notice in your standard form, you have a number that's being multiplied by y minus something, or y plus something even. So you want to leave it in that form, because this is a special number for that parabola, and again we'll talk about it later when we talk about just parabolas. We're going to have each day is going to be represented by one of these conics that we're going to study for this next unit. The other thing that you might want to do is just totally rearrange this equation. Just move everything on the right over to the left and vice versa. You don't have to change the signs when you do that. You're just rearranging the equation. So put the x plus 1 squared over here, and put the 8 times y minus 4 over here. And that way you have an equation that looks just like the standard form. Alright, so let's look at this next one. This next one is 5y squared minus x squared equals 25. So hopefully this minus is a red flag to you that this is a hyperbola. Hyperbola, again, is the only one that will have a minus between two values being squared. The other thing that you should remember about the hyperbola is that it is equal to 1 in the standard form. So to get this one started, we want to get this equal to 1. Well, the only way I could get it equal to 1 is to divide everything by 25. So I'm going to divide everything by 25. Now, what you'll hopefully realize is that the 5 can get canceled with the 25 here and make that 5. So this is going to simplify to be y squared over 5 minus x squared over 25, because I didn't have anything that would cancel there, and now it's equal to 1. So this one was real easy. And then what you would want to recognize, and I think I communicated this earlier, it's not the biggest number that represents how the hyperbola opens, it's the lead one. So I should go back and go over that again. So this is what's leading the hyperbola, the y value. So this hyperbola is going to open up, down. So if you copied that down in your notes, you might want to go back and change that. So this is your final equation. And that's not a negative, okay. Okay, the next equation, 6x squared plus 6y squared equals 600. So you might be thinking, okay, this looks like it could be a circle or it could be an ellipse. It's a plus in between two things being squared, so it's got to be one of those. The way you can tell is that these coefficients are the same, and so therefore it is a circle. And if you remember, the circle looks like this, x minus h squared plus y minus k squared, and it's equal to the radius squared. So it doesn't have to equal 1, it just equals the radius squared. But if you'll notice, it does not have any coefficients, so that means I need these coefficients to be 1. So I need to divide everything by 6 in order to get those coefficients to be 1. So I'll have x squared plus y squared, and that's going to equal 100. So if I asked you what the center was for this equation, because there's no h or k that's being added or subtracted, then that means my center is at 0, 0. And then my radius, if you'll remember, you take the square root of that last number, so it would be 10. Okay, this is the last example. X plus 2y squared equals 5. It only has one variable that's being squared, so that means it is a parabola. And since the y value is being squared, we need it to look like this. Y minus k squared equals 4p times x minus h. So again, we need to get the squared term by itself. So we're going to subtract x over to the other side. So we'll have 2y squared equals negative x plus 5. Okay, but that x cannot be negative, so we need to divide out the negative. And actually, let me wait to divide out that negative. Let's go ahead and, well, hang on, let me get that off. Well, never mind, I can't really erase it. Let me just write it again, negative x plus 5. The first thing we're going to do is we're going to divide by 2. Okay, so, and then what we're going to do is we are going to go ahead and divide by that negative. So y squared is equal to, if I divide the numerator by a negative, then I'll have x minus 5 over 2. And then because we want a number to be out front, if this number is a negative 1 on top, if I divide that by 2, we're just going to write it like this. Y squared equals, we're going to bring that negative 1/2 out front and just multiply it by x minus 5. Okay, it's the same thing. This is the same thing as this, but we just want to make sure that we're writing it in proper form. And so this would be the equation for the parabola. Okay guys, I know this is probably a little confusing, but we'll do plenty of practice when you come to class. All right, have a good evening.